Welcome all, my name is Ermin, and I do have a habit of making these intro videos for pretty much all of my courses. So in these intro videos, I like to discuss the particular things about the course, some extra features that you get, and just things in general. Usually a pretty short video. I would advise you to watch it all the way to the end, even though I won't do any demonstrations here on how to use Bash and such things. This video is primarily intended to give you bearings on the course itself and to explain some additional features that will be available to you along with the course. So first of all, why should you learn Bash? What is it good for? Well, as a Linux user, rest assured that you will need to be familiar with the Linux command line. It is a necessity, and even though you can do most things with GUI, graphical user interfaces can be buggy, they can be problematic, they are far more vulnerable to exploitation. Plus, on top of that, if you have a server anywhere in the cloud, and any server that you manage out there in the cloud, if it's a Linux server, and most of them are Linux servers, you will need to do it via the command line, or at least via the web interface, but mostly via the command line, because nobody really wants to install a server with a graphical user interface. The reasons for this are numerous. First of all, it costs far more, as it takes a considerable amount of space on the disks, for which of course you have to pay, and also the bandwidth is greater when managing these servers, because if you're running some sort of a remote desktop protocol or something like that, it's a very painful thing, especially because you need very fast connections for that to work. While on the other hand, if you're using SSH from the Linux terminal and are managing a server somewhere via the command line, you can basically do it in a 56 kilobits connection. It's not a big deal. It's going to work unless you need to upload or download some bigger files. Then you would need a bit of a faster connection, but the commands, the management itself will fly pretty much. And above all of that, just think of it in this fashion. All the power of the user rests here in the terminal. The terminal empowers the user. It enables you to do all sorts of great things, and you have a far wider variety of options as opposed to GUI. You actually have the control over things. You know what is going on. You actually see how certain things are done, as opposed to just clicking a button somewhere. So you learn nothing or very little by clicking that button while using GUI. While on the other hand, if you're using the terminal, you will learn a great deal about the operating system, about the programs that you use, about the programs that are running in the background, how things are kept together, how things function, etc. I'm not saying that the path ahead is easy, but Bash is definitely a lot easier to use for creating scripts, etc., than some other languages are. Basically, if you were to use Python, okay, Python is still very nice and convenient, but let's say you were to use C. I mean, it's a very powerful language. It's great. I personally love it, but it's kind of difficult, and the syntax is not very attuned to human mind. Let's put it so. It's more attuned to the machine than it is to a human. While on the other hand, the syntax in Bash is very simple, fairly straightforward, easy to understand. There are some things which need to be explained in depth and so on, but it's not as hard to understand as some other languages are, some others can truly be a drag with all sorts of notations and such things, but Bash is not. Bash is fairly simple, straightforward, easy to learn. And you should be able to, after the completion of this course, to be able to handle Linux terminal and Bash without much difficulty. Even though there are some 2,000 commands in the Linux terminal, You, of course, will almost never need to know all 2000 commands. There is simply no need for it. But you will learn a good amount of them in this tutorial, probably more in these tutorials, probably more than you will ever need. But I like to leave it just in case to explain things. Anyway, in the videos below, you will see setup videos. You will find setup videos in the tutorials below. Actually, you will find setup videos that will show you how you can set up a Linux machine within Windows. There are multiple setups available. I have chosen to explain only a single setup. I have learned from the previous tutorials, when you give too many options, when you show your students in general, I don't know, how to create a dual boot, how to create a live boot off of a USB, how to do a virtual machine, etc. When you give all those options in one place, people tend to get confused a lot. So I decided to go with the simplest possible setup. I decided to show you how you can install a virtual machine of Linux on a Windows with ease, without any problems, and to use that particular setup. I myself, I'm running a Linux machine as my main desktop machine. I'm running Linux operating system as my on my main desktop machine, and I have been running it for, I don't know, at this point of time, I think it's been 8 years, something like that, and I've seen a lot of changes over that span of time. Anyway, in case something remains unclear, or if you want to ask about something, there's always the tech support in the discussion section. There are people who are paid who will provide answers to your questions, who are happy to do it. If you pose a question, somebody will be there and they will post a reply trying to help you out. When you ask for help, please do it. When you ask for help, basically try to describe your problem as much as you can immediately. So get the list of steps to reproduce your problem so that the person on the other side can reproduce the problem and solve it. I'm not saying this so that it is easier for us to do something so that we invest less effort or something like that. No, I'm saying this primarily because of you. Why? Well, because you will only wait for an answer longer if somebody needs to ask you additional questions, then you need to provide answers, and then somebody again needs to provide answers. So you're playing a back and forth game instead of just formulating the question the first time around in a proper way by actually specifying and stating how to reproduce a particular problem. If you can't do it, it's fine. Just describe your problem the best you can, and somebody will be there to assist you in whatever manner they can. And we are happy to do it. So that's one of the things that you get with this course. There's a tech support in the discussion section, and we're always happy to help you out pretty much any way we can. This is the case with all of my courses. Now, next up, you also have a YouTube channel that you can visit. I will provide links in the description. And I generally like to place videos there that are solutions to certain problems which students encounter here on Udemy. So they find a problem within a course, and I don't know, the versions differ, their version differs of the operating system and mine, or the versions of the programs differ, something doesn't work, and then I like to upload videos to YouTube and post solutions there for my students from Udemy. So really there are some videos there that provide some nice solutions and instructions on, also amongst other things, on other setups. I mean, how to make a bootable USB dual boot, how to create a virtual machine on a Mac, etc. There are lots of useful videos there, so feel free to check it out. I mean, it's completely free. You don't need to register or anything like that. You can just go ahead and check it out if you like, or you can actually ask for some videos to solve certain problems, and I can post them there for you as well. I mean, again, completely free. There's no charge there. There's no registration or anything like that. You do not have to do any surveys or anything similar. It's completely free. You basically open up YouTube and watch the video. It's just like that. And the final thing that I would like to mention in this intro video is the fact that I am a human being. I am available. I'm just a regular guy. I am not like a lot of other people. When they have a lot of students, you cannot reach them. You can always reach me. You can always talk to me. You can always send me a private message. I might not respond straight away because I get a lot of them, but I will respond. And if I don't respond immediately, feel free to send me another message, because your message, I could have wanted to, I had an intent to answer you, but your message got lost. So if I didn't answer you, just send it to me again. Say, hey, you didn't answer me. Come on, what is up with that? And I will be happy to do it. I check my messages pretty much on a daily basis. So it doesn't matter what your question is. You can pretty much ask me, what is the weather going to be like in LA tomorrow? What I am going to do in that situation is go ahead and open up my browser and look at the weather forecast for LA for tomorrow. And I will give you a response and probably give you a link of reference where I got the information from. So I am reachable. I am somebody who is there for you if you need me. I'm happy to help you out. I even pay people to help you out in the discussion section. And plus you can talk to me about pretty much whatever. Ask me questions. I'll be happy to answer all the private messages you send. You can even see me sometimes in the discussion section as well. Anyway, bid you all farewell, and I wish you a download of luck with this course. Welcome back all. So today I shall show you how you can set up a Linux virtual machine within Windows. Now there are multiple options available for setups. You can have dual boot, you can have a live USB that you plug into your machine, but dual boot with Windows 10 is kind of difficult. I mean, it can be problematic, let's put it like that. Ever since Windows 8 was implemented, dual booting with Linux has become increasingly more difficult. Anyway, if you want to check out the videos for dual boot, if you want to mess around with that, I've placed some on my YouTube channel, so you can have a look at them there. But here for this course, I figured we would just use a virtual machine and see how things work. Simple as that. If you also want to create a live USB, you will be able to find videos about that on my YouTube channel. It's completely free. You're not required to register or pay for anything. The videos are there. I primarily made them actually for Udemy students from my other courses. You can have a look if you want some other setups, but I'm going to show you this setup simply because it's the simplest one, nothing more. Anyway, so first of all, open up your favorite browser. And I am on my friend's computer here. I generally use Firefox and I don't use Windows, so I just came to my friend's house to actually record this part. And there are two things that you will need. So first of all, you will need your favorite Linux distribution. I am using Fedora, but there really is no reason why you wouldn't be able to use some other Linux distribution. You could use Ubuntu or whatever you want. Pretty much the same things should work more or less. And you will also need VirtualBox that you will need to download. You will have the links in the description, so no worries there. You will need to download that as well. But before you go into downloads, go ahead and open up your system info on Windows. Basically just go to this PC and then computer and then properties, and then this window in front of you will open. Now first of all, take a look at which processor do you have. It says here Intel Core i5 6600K CPU. You do not require a CPU of this power for this particular course. You can pretty much work with very old processors. I personally have on my laptop, I think I have some sort of an i7 that goes way back. But that's not the point. This should work on pretty much any processor. However, virtualization might be problematic if your CPU does not support virtualization at all. If you're Intel or if you're an Intel user or an AMD user, you can go over to the Intel or AMD website and check the technical specifications of your processor. Like 99% of the time, it should work without any problems, and you shouldn't have to check this. Next important thing is to know how much available RAM do you have. So he has 16 gigs. Again, you won't need 16 gigs. You can get away with like 8 gigabytes of RAM on your machine, and for everything to be smooth and practical to go with no problems. Down below, this is quite important. It says system type 64-bit operating system. Now I will go ahead and download VirtualBox now from the download link. And it says here VirtualBox 5012 for Windows hosts. So just go ahead and download the first one. If your machine is 32-bit, it should by default offer you the one for 32-bit as well. That is how it works on the Fedora website. You just go over to the Fedora and then you click on workstation. Actually, you can just click on download now. Download Fedora 23 workstation. Sure, why not? And it says it should begin in a few seconds. If not, just click the link down below. So if it doesn't actually begin, just click the link. No big deal there. So the internet connection here is, I would say, relatively fast. It's not the fastest. It doesn't have the fastest of internet connections. So the download time is actually 4 minutes, which is a bit painful. The file is not that big. It's 1.4 gigabyte. So it should download fairly fast. But as I said, there's no reason why you cannot use some other distribution, although I will be using Fedora and I will be doing the demos in Fedora itself. Also, I am using a VirtualBox. If you want to use VMware or some other hypervisor, you are by all means free to do so. There is no reason why it shouldn't work. You just need to know how to configure it, that is all. But I know from previous courses that a lot of people on Udemy are using VMware or Parallels or something like that. So completely irrelevant. Just go ahead and download VirtualBox without any problems, or VMware or Parallels or whatever other you want. Key thing to note is that you should never have more than one hypervisor on your machine. Either have VirtualBox or VMware or something else. Whatever you install, make sure to uninstall the other one before you install the new one. Be very careful about that, as that can lead to a lot of problems. Also, if there are any Mac users out there, if you just send me a request or something like that in the discussion section, or just if you send me a PM to create a setup video for Mac, I can do that as well. But if you don't want to bother, you can just check out my YouTube videos. There will be a section on how to set up a VirtualBox on a Mac and how to install Linux there within a VirtualBox, so you can see it there as well. But if there are enough requests, I can post instruction videos for Mac users as well. Although there is nothing really that different. You basically just install VirtualBox on a Mac the same way you would install any other software. You can see here it says VirtualBox 5012 for OS X hosts. And then you download Fedora, and the process from that point on is pretty much the same. There are no significant differences in my opinion anyway. I've done the installation on both systems. I generally don't use Mac. I have bought a MacBook Pro from 2011 so that I could better help people on Udemy who are using Mac, so that I can understand their problems and see how it actually works. My experience with the OS X is somewhat limited, but I generally didn't really enjoy it that much. Anyway, I don't have anything against it. It's a pretty good operating system. But also, in terms of Bash, you should be able to do most of the things that I'm doing in Linux within the Mac terminal as well, because most of the things in this course will be done in the terminal, if not all of them. So you can just pretty much do the same things on a Mac, open up a terminal and write Bash scripts there. Most of the things should work, although no guarantees there. The download should finish in about 20 seconds, so that should be fine. I know I should have downloaded this sooner. Anyway, let's go ahead and begin the installation of VirtualBox. Okay, always asked before, run. Next. Sure, why not? Next, process, yes. It will reset your internet connection in all likelihood, but it shouldn't affect the download too much. Install, yes. The installation process is fairly fast and straightforward. Now just go ahead and install this, because you might need it at some point of time. Okay, sure, start it afterwards. And there we have it. So we have VirtualBox here. It's up and running, no big deal, fully functional without any problems of whatsoever. Now you're gonna go ahead and click on New, and if you are using Fedora or if you're using Ubuntu, well, simply just type the name of the operating system, or name your system whatever you like, in fact, just whatever you like. Here, I shall name this Fedora. Oops, Fedora. I hate his keyboard, but it's okay. It says here Linux, so select Linux, and down here it says 64-bit because this is a 64-bit system. I'm going to select 64-bit. Now, key note here. Good amount of you, well, maybe not good amount, but let's say that maybe 10 to 15% of the people will not have virtualization enabled in BIOS, and that might affect you in a sense that you will only have 32-bit options. In that case, you have two things that you can do. You can either go to BIOS and enable virtualization, or you can go to the Fedora website and actually download the 32-bit version. Here, I do believe that it's here somewhere. It should be Fedora Spins. Yep, there we go. Fedora Spins. And I don't know where it is. This is unless downloading. It should be around here somewhere. You know what? Forget it. Let's just type in Fedora download 32-bit. By the way, only download from the official website. Don't go like God knows where downloading. So only from the official website. Don't go to some other places. Okay, fine. Let's go into the workstation. It should be here. Please tell me that it is here. Why are you not giving me the option to actually go for the 32-bit? Is beyond me. Come on, get Fedora workstation. There we go. So it says other downloads, and it's 32-bit image. It's a little bit smaller, but I mean, you're not going to be deprived in any way if you download a 32-bit image and use a 32-bit system. For what we're going to do in this tutorial, it literally will not make a difference to you. So if I just go to Fedora, I want to show you the path once again, even though I'll leave the link. So you just go to Fedora, download now, and instead of clicking this default download button, you just select the 32-bit image if you only have the 32-bit options here, even though your system is 64-bit. Or, if you like, you can go into your own BIOS and enable virtualization. Just look for something to do with virtualization. So on some motherboards, it is disabled by default due to some precautionary measures. Anyway, just go ahead and click on Next. Assign the amount of RAM. I would suggest assigning at least 3 gigs, but you can get away with less than 2. So no big deal. You can get away with less than 2. The system should run just fine and smooth without any problems. So go ahead and click on Next. But if you can spare the 3 gigabytes, it's always nice because it makes your virtual machine run a little bit smoother. But 3 gigabytes, let's understand one another, is an overkill. Seriously, for this. You can get away with far less. Anyway, create a virtual hard disk now. Yes, please. Just go ahead and click on Next. Next, and what should be the size of your virtual disk? Now, please do not go below 30 gigabytes. 30 gigabytes is the bare minimum, in my opinion anyway. Anything below, you might have some problems, you might not, but I would suggest to go with 30 gigabytes just to be on the safe side. So make sure to change this and to set it at 30 gigabytes, and make sure that you actually have 30 gigabytes of free space on your drives, as you can see here. Create. Excellent. So now this is done. Just go ahead and right click on it, go into Settings, Storage, where it says Empty, click on it, click on this disk, choose a virtual optical disk file, go into Downloads, Fedora Live Workstation, click on it, click on open, OK, and then just power the machine on. So, yep, there we go, the machine is powering on. Start Fedora Live. You basically begin the installation by actually starting the live version, running the live version, and then beginning the installation from the live version. Sorry. Anyway, I shall go ahead and wait until the machine boots. Keep in mind also that you won't have a full screen immediately. It will be like this, and later on we will convert it into a full screen. So let's go ahead and click on install to hard drive, but actually wait. Go ahead and click in on the devices, network settings. For the time being, make sure that it's in NAT mode and that you are connected to the internet. So make sure that you are connected to the internet, and then check the virtual machine. It says PCI Ethernet connected. Okay, good. Now go ahead and click to install to hard drive. Just make sure that you are connected. The VM is connected and that your host machine is actually connected as well. So just go ahead and choose the language that you wish. No, I don't need R, I need E. There we go. And I need N, and it's English. States. Okay, so just go ahead and click on, actually, I'm gonna select UK for myself, but you can select whatever you wish. Go ahead and continue. Okay, so keyboard UK, time, date, and network and host name. It says connected, so that needs to say connected there. If it's not connected, the installation will still run fine, but I would suggest that it is. Just click on done here, so you open it and then you click on done. You click on installation destination and you just click on done, because you only have one virtual hard disk anyway. It should not touch it shouldn't touch the rest of your file system. And go ahead and click begin installation. So root password, go ahead and set the root password here. If you type in a weak password, it will demand that you click done twice. I would suggest that you put something appropriate. And then the user creation. Please do not forget your root password and do not forget your user password. That's like quite important. So let's go ahead and type in the username. You can type in the full name if you like. That's just, I'm just gonna type nonsense here. Like, it's just gonna be test. But just type in your own username and type in your own password. That's really all you need to do. Go ahead and click on done. You need to click on done twice again if the password is weak. Anyway, I shall leave you here and wait for the installation to finish, and then I shall come back to do the rest of the work.
Welcome all. Now I shall talk about variables and parameters in Bash. So variables, they're basically labels or some sort of names used to represent certain values or sets of values stored somewhere in the computer's memory. We can use variables both for arithmetic operations and string phrasing. This we will work out through a series of examples as always. Now what is important to understand is that the variable name and its value are not the same. Let's say we have a variable num, or number basically, or just let's say, actually let's do a better example. Let's say that we have a variable called var, so the var. Then var represents the variable name. To get the value of the variable, we used to add a $sign as a prefix to the var, to the variable name. So this we have used many times by now in the examples, but let's just go ahead and see how that actually works. Let me just go ahead and explain that part in particular. So vim, and now we're still going to stick to the first. I don't know, when we get to the major chapter change, like when we skip on from basics onwards, I think I shall change the script name to second or something like that. But you can name it whatever you want. Mine is first.sh. If yours is something else, that's perfectly fine. So as before, we can type in, I always click on the second screen where I have my notes, so sometimes don't click it immediately here. Excellent. So now we're in insert mode. Let's type in var equals 10. And if we echo var, that will actually not echo the value of this. It will just echo literally letters VAR. And down below, we can use what we have been using thus far, var. So these are two completely different statements with dramatically different effects. You see, it will output var, and down below it will output 10. So the name of a variable is not the same as the value of the variable. So we have to use this $sign as a prefix if we want to work with variables. However, there are some situations when a variable doesn't actually require a $sign. So let's just go over them. The first one, can you spot the first one on the screen now? The first one is in the declaration part. So you just type in the declaration and then you assign a value to it. So obviously you don't need a $sign here to assign a value to a variable. Now there is something called unset, and we can say num. Well, not num, we can say var. In my notes over here it's num, but for some reason I placed it num, I suppose, because I'm using numbers as demonstrations for demonstrative purposes, but doesn't really matter. So if we type in unset var, this will actually make var into null. So if we type in echo var, you see, there is literally nothing that is printed out. So it's not being converted to number 0, but null. So there is nothing in it. There are some cases of exporting, but we're going to do that later on. I don't want to burden you with it now during the section that deals with basics. That's a little bit more of an advanced subject. And there is just another example which I would like to illustrate before you. There are some others, but as I said, we'll deal with them as the course progresses. But if we have these parentheses, then you will not need them. Which is basically, again, setting the value. If you remember, we used to use var1, and we've set var1 equal to some number. I don't know, let's say 4. And down below, we have created these parentheses where we have stated that var2, where we made var2 dependent on var1 value. And then we said like lesser than, I don't know, 10, lesser than 10, then we shall place a question mark 1 and a 0 here, and then we shall close these, and down below you can type in echo var2. So you see, we didn't need a $sign here. So we are assigning a value here, obviously, okay, but what of this? So we're just using the name. So in situations like these, you won't need a $sign. These are very specific cases. But I suppose you're going to know it by the rules, but eventually it will just become second nature to you and you won't actually think about it that much. It will just seem right. The same way you can speak English language. Let's say you were born into it or you have learned it, and after a certain time of speaking, you basically stop thinking about it. You basically stop thinking whether the grammar is correct or false, and 90% of the time it turns out to be correct and people can understand you. Well, this is also a type of a language that you use and that you learn. So after you've learned it, you're obviously not going to rethink grammar every time. Rather, instead, it's just going to come intuitively to you. Okay, so let's move on. We can assign variables in 3 ways. First way, and the most obvious way, is the one that we have just used. So we have stated var1 equal to 4. Now there is another way in which we can assign variables, and that is from the read statements. So the read statement will actually read the user input, will actually take the user input and put it into a variable. Here's how that looks like. This is also used rather often. Read, and we shall state var2. But before this, let's just make it meaningful. I mean, there's no technical requirement for this, but this is for our convenience. Echo, type in some value. Excellent. And then we're going to say read var2, and after that we shall echo var2. Fantastic. Now let's run the script. It says type in some value, and it's waiting for us. Actually, let's quit it. Let me just clear the screen so you can see it better. Type in some value, and now it's waiting for me to actually type it in. So what shall I do? Well, let's type in 8. And there you go. It prints 8 out onto the screen. Very simple. So we can also assign values to variables in this fashion, which is very nice. The third is, well, it's kind of used in a loop. Here, let me show you. It's not kind of used in a loop. It is used in a loop, but to an extent, I guess. Look at this. If I, for example, use a for loop, we will deal with loops separately, so I don't have to worry about that. So for var in, I don't know, 1, 2, 3. So this var is basically a variable, and 1, 2, and 3, they represent a list of arguments for the loop. And this is going to go through 3 iterations, and variable var will take on the next value in the list. For each iteration, this variable will take, let's say in the first iteration it will take the value of 1, second iteration value of 2, third iteration the value of 3. Here, let me just show you this. It's rather simple. Echo $var, done. Right? And there you go. So it prints echo var. Well, let's make it even clearer than this. And let's state echo $var. Oops. Let's do it like this. What does the matter? Oh, okay. Value of var, sorry if I misspelled that, value of var is, and excellent. So let's go ahead and write that, and let's run the script again. So it says value of var is 1, value of var is 2, value of var is 3. So that is how you assign these values to, that is how you assign values to a variable. Anyway, I'm going to cut the tutorial here, bid you farewell, and we shall continue on in the next one. Welcome back all. Today I will talk about return values. So, when writing a script, it is important to know if the script executed successfully or not. Why is this important? Well, aside from the obvious reasons, sometimes you will run a script and you will not know whether it executed properly or not unless you are familiar with return values. One of the most confusing things for beginners in Linux tends to be the return value or the return value of 0. So when you run a command and nothing happens, that is usually a good thing in Linux when there's no feedback. I know, right? Strange. Here, let me just give you a small example. You will need to switch your user to root. Just type in su, press enter, and then type in the password. I already have a terminal opened here, so I just decided to drag it from another screen. And if I, for example, use this command to basically set the status of a certain service, so if I type in system ctl status, or let's just type in restart httpd dot service. What? Nothing happened. I just issued a command to restart my web server and I didn't get any output. Like, what is wrong with this? What is missing with this picture? What is missing in this picture? Well, nothing. Everything went fine. Everything is perfect. That is the return value of 0. If you run it, if nothing happens down below, fantastic, the command ran. I will demonstrate this further.
But for example, if you something, you see, if I attempt to restart a non-existent service, it says fail to restart something.service unit something.service failed to load no such file or directory. It's going to issue out an error message, and this is also a return value. So in Bash, we have we will revisit this, so do not worry. I just want to give you a quick demo of what it means to return a 0, and why is that a good thing, and why anything but 0 is generally a bad thing, and the fact that it's a little bit difficult to get used to zero feedback from the system. Like, for example, when I restart my web server, the return value is 0, everything went fine, but if I didn't know that, I would have no way, I would have a way of knowing it, of course, but just by looking at the screen, I wouldn't know really, did my command ran or not, what happened, etc. So anyway, in Bash, we have an exit command that is in charge of terminating script execution and giving us the status of the script execution. So the status is available to the script's parent's process. For example, this terminal, if I run a script from it, this is gonna the exit status will be available in this terminal, just like to the systemctl. Just like when I ran systemctl, the exit status was printed out here on the terminal. This is also another exit status. It's an error. It failed to load. And just keep in mind that even if the script doesn't have exit command, exit status is returned. And in that case, it holds the status of the last executed command in the script. Very important to keep in mind. The exit command, I will demonstrate it, of course, but let me just give you a little bit of dry talk and then we'll go immediately into examples. Exit command can be done, can be with and without parameters. But usually, the parameter that is given to the exit command is $? So this, $? What is this? Well, $? holds the exit status of the last command that was executed in a function, which is equivalent to the return values in other programming languages. I'm guessing that you're not coming from some sort of a heavy programming background, so you're not that familiar with this, but the case is pretty much similar across the board in pretty much all the programming languages out there. Functions, which we will deal with later on, they all have some sort of return values unless it's a void function which doesn't have a return value, etc. So the return value can be a lot of things. It can be a string, it can be an integer, it can be a single character, it can be I don't know, just as many variables as there are. Pretty much that is how many types of return values you can have. Anyway, let's go ahead and take a look at the example and see what this actually means. Let's just open up, oops, I'm not gonna do it in the root terminal, no need to do that. By the way, these scripts that we are writing, unless I designate it so, please don't run them as root. There is no need for it. I'm guessing that you won't do it, but even if you do it, in general, you won't really cause that much harm anyway. But just stick to the safe side and use it as a regular user, and you should be fine either way, but it's much better to run it as a regular user. Anyway, so let's go ahead and type in vim first.sh, and as you can see, I am a regular user. It says chronic at my domain. My domain is the host name of this machine. So let's go ahead and type in echo and type in tralalala. Excellent. Down below, we shall type in echo again, $? So what do you think that this is going to output? Just think about it. Why did I quit? I have no idea. It says tra-la-la-la, everything went fine, and then the return is 0. That's good, no problems. But if I go ahead and type something in, just smash my keyboard like this, well, just smash my keyboard in terms of letters, because I don't feel like doing this 100 times. If I run it, what do we have here? It says /first.sh line 5 trala something command not found. Exit code 127. Now, since this is not a command, and since exit status is not 0, but some other integer value indicating that the last command was not successful for whatever reason, 127 is the value of the exit status. It can be traced to a particular error, as pretty much all the error codes are listed, are well documented, and you can find them without much problems either on the net. You basically type in bash error code 127 or bash error code, etc., and you should be able to find it without any problems. But here you can really see what it says. I mean, it's literally telling you what the problem is, so you don't have to actually go and look for the error code or anything like that. You can also find them in Linux as well. It says that the command was not found. It doesn't recognize this particular command. And this is why $? Is very useful when it comes to testing commands in a script for whatever reasons. I mean, if you run a command and you wish to know whether it works or not, well, you just put $? Below it and run the program once. Have a look. If it throws out an error code, you'll be able to figure out based on that error code what the problem is, because you will also get a message as well. So you don't have to be that concerned about it. But it's very nice that you can actually print yourself an error code, and then when you go onto the forums or something like that, hey, you can say, I got this error code, this is the problem, could you help me out? Here's my script and here's my error code, and I get the error code on this line for this command. And obviously then people will be far more forthcoming, as opposed to you just pasting a script somewhere on the forum and stating, hey, I have a problem here, it doesn't work. The next post below you will be, can you give us something more? Can you explain something more? Usually what people will ask immediately, what sort of an error did you get? What was the problem? But when you put it like this, somebody was able to help you out immediately, as opposed to somebody posting and then you posting after them, and then they posting back again, asking you more questions, etc. Anyway, let's go ahead and continue with our script. So let's define a couple of variables. Let's first delete this and type in no, so number of, sure, why not? Number of args equals 2. And this will be the number of arguments needed. The next thing that we want to do is define our exit status. So if incorrect number of arguments is passed, we should have this. So E underline, how shall we name this? I don't know, bad args. Bad args, I guess, is fine. 85, and E underline, so this will be, for example, we shall have this error code if we are unable to read we shall have this exit status if the program is actually unable to read a certain file. Let's put it like that. So I am a wonderful speller. Unreadable. Thank you very much. So 86. And let's go ahead and start typing. So if, make sure to place a space here, bracket, and we shall have a $ hash dash any space quotation marks, and then we shall reference a variable args. Excellent. So let's just go ahead and type in then. Fantastic. So what this means in this, what this condition represents, it basically states if the number of command line arguments is not equal, so the number of command line arguments, I'm selecting it, so this has that meaning, the symbol $sign hash. If the number of command line arguments is not equal, so NE, not equal, and then we're referencing this variable, so we get the value is not equal to the number of args that we have specified, we want something to happen. So let's go ahead and jump into that. Then echo, and we shall type in usage, and we need, oops, yep, there we go, reverse quote marks, base name, space $0, reverse quote marks, I don't know, let's type in test file 1, test file 2, and let's type in the exit. I'll explain in a moment. Let me just type it in. It's a little bit easier like that since it's a bit more complex script. It's not really complex, but args, I don't want to really miss anything here. Bad args, and we're gonna finish it. We shall finish the if statement. Anyway, so now that we have defined the condition, the base name will basically print out $0. What is a $0? Here, do you remember from the previous lessons? It is the name of the script. It is the name of this script that we are writing now. This is used for usage messages. If the script was called, but not all required arguments were passed to the script. So we would like the exit status. The exit status will be 85 as we have defined it. So we have 85 here. It says bad args, and the exit status will print that out if this condition is not satisfied. So if we don't pass exactly 2 arguments, then we're going to have a problem on our hands. That way you can actually make it mandatory for users to pass a certain amount of arguments or a certain range of arguments to a script, which is also a common practice with Linux commands. Some of the commands, when you run them, they have mandatory positions. They have mandatory arguments which you need to specify. And if you don't specify them, it throws you an error message and it opens up a help menu which gives you a syntax and a list of arguments which you can pass in order to help you out. So now that we have finished this loop, we are going to continue on writing this beautiful script of ours, which is going to go on for a bit longer, and then we're going to run it, and we shall see. As I said, the scripts will progressively get more and more complex, and we will get to the point of time where we will have a pretty big script. So I might just open it up for you and not type it in like this, not to waste time. Anyway, let's go ahead and type in if, bracket, exclamation mark, dash R, quotation marks, $1, close quotation marks, or exclamation mark, R, $2, and let's go ahead and close this. Then, okay, should be fine. If
I didn't mess anything up here. Okay, it should be fine. Anyway, -r will return true if the file exits and it is reasonable. It is readable. So -r will return true if the file exits and is readable. The exclamation mark is logical not, as I have explained before. It reverses the test result. So if either of these files does not exist or is not readable, we will define the exit status down below, which will be 86 as we have defined it up here. But the coloration seems to be a little bit off here, and I'm thinking of what it is that I wrote wrong here, but I can't really see anything. It's probably something stupid that I have overlooked while typing. But oh well, let's have a look and let's troubleshoot it in a moment. So if we type in then, we shall type in echo files are real. Let's put it like that. I was thinking of writing files are in existence or they are readable or something meaningful like that, but let's go ahead and type in files are real. Exit, and let's go ahead and reference our exit and reference e underline unreadable. There we go. So with that, we can finish our loop. Now let's go ahead and run this and see what happens. Are we going to get any error messages? Is it going to be fine? And of course, we have a problem. So line 17, what is EOF? What does that mean? It means end of file. Very important marcation, which we will be utilizing at later points of time. And then we have an unexpected end of file. So there is a problem somewhere within this script, but I would solve it now, but I'm literally at 19 minutes and 30 seconds. So I'm running out of time. The videos need to be 20 minutes each, and we'll get into troubleshooting in the follow-up tutorial. I do believe that the troubleshooting part is actually useful for you, and that is why I always leave it in the videos. Welcome back. Today I'm going to go ahead and talk a little bit about conditions. So no big deal. We have already done the conditional statements before. We have seen how they function in examples plenty of times before, but there are a few cases which I have not shown you up to this point of time. So let's go ahead and take a look at a few examples. Not going to burden you too much. Let's define a variable called num, and let's say that that variable's value, let's assign a value to that variable of 1. Then we shall use an if statement, and within the if statement we shall say num greater than a zero. Let's close it. Then, and now within the then portion, we can go ahead and place another loop. So if it is greater than 0, let's go ahead and check if it is lesser than 5. And then we can create another one. So like this. So if if num is greater than 0 and it is lesser than 5, we would like to know if it is greater than 3. And then we can go ahead and type in echo greater than 0, lesser than 5, and my bad here, dash greater than, my apologies, lesser than 5 and greater than 3, so that we know where we are. That was long. After this, we can go ahead and finish these statements. You see how we finish them? We need to put F5 for each one of these. And then we can use elif num is, I don't know, equal to. So equal to 0, echo out equal to 0, else echo out I have no idea. That was a long one. There we go. So now you can see how these things can be nested practically infinitely. You can nest them as much as you want, as long as you just follow the form and the procedures given. So if you start an if statement, you need to finish it with fi. So you see finish, finish, and at the end we have a finish again. So no big deal. We can do it rather fast, no big deal. And in general, you will need to place a good amount of these statements. I mean, you will need them of that. I assure you, there's no going around these sort of coding practices. You need to test out one condition, and then if that condition is true, you need to test out another one and another one, etc. It keeps on iterating on end. It can be quite complex at times. Now let's go ahead and take a look at some of the. I mean, you have these things called file test operators, and let's go ahead and take a look at some of them, how they function, how they work, what they're good for, what they're meant for, etc. So first off, we can go ahead and type in var, and within var we can actually place a path to some sort of a file. So variables can store paths. It doesn't matter that it's longer. So we type in home and slash chronic slash wood.txt. This one should be here. And do you remember the last tutorial where I asked you to do something on your own to check individual existence of files? Well, this can be a part of the solution. This can be one way in which such a problem can be solved. If you go ahead and type in if, and then you type in double brackets, you should generally use these in order to avoid some sort of confusion in terms of logic later on. So I advise you to use the double ones if you can. If not, oh well. -e, then we shall use var, and we shall close it back up again. And -e will actually test is a file test operator that checks if the file exists at all. Then echo file exists, else echo file does not exist. How I have managed to spell this so badly is beyond me. File exists. There we go. And remember, we need to close here, and we need to close this statement. So this entire script, it simply checks whether a file exists or not. So let's go ahead and run the script. I know that I didn't run the last one, but I don't think there was a purpose. You've seen a lot of these
if and then statements. I just want to show you how you can nest them, pretty much the same thing, but we're going to run this one. And there you go. It states that the file does indeed exist because we do have a file, wood.txt. As you can see, it says wood.txt. It does indeed exist. And if we type in pwd, that command will tell us where we currently are. What is our working directory? In fact, it stands for print working directory, and that is exactly what it does. Home, chronic, and then / wood would be the location of this particular test file. And this you can use, this piece of code you can use to actually check for the existence of individual files in combination with nested loops in the previous tutorial in order to complete the task that I've set for you there if you so choose and if you so wish. Anyway, the next construct that will be used in conditional statements, basically double parentheses. Let's go ahead, let's go ahead and take a look at them and see how they actually function and work. Something like this. So double parentheses here, double parentheses here. Let's have a look. So if we see, this construct returns exit status, and by this construct I mean this and this. This is practically the construct to which I am referring, the parentheses. So it will return the exit status after evaluating some sort of an arithmetic expression. If the result of the arithmetic expression is a 0, then the exit status is 1 or false. If the result of the arithmetic expression is some non-zero value, then the exit status is 0 or true. So once again, if you have a result within these parentheses, a result of some sort of an arithmetic expression, so if the result is 0, then the exit status is 1 or false, because 0 stands for false, 1 stands for true, basically, in essence, in general. But you see, it can be confusing. I just said 0 and then I said that the exit status is 1. Well, if the result is 0, then the exit status will be 1 or false, so 1 false. And if the result of the arithmetic expression is some non-zero value, then the exit status will be 0 or true. Let's have a look at this. I know it can be a little bit confusing. Trust me, I have banged my head over this when I was learning it, so I do understand you to a good extent. If we say that 2 is greater than 1, so is 2 greater than 1? Yes, it's greater than 1. Echo exit status is, and let's go ahead and how do we get the exit status? Well, $, question mark. There we go. Let's run it. Exit status. Status. There we go. So let's run the script one more time. So exit status is 0, meaning that this expression is true because 2 is greater than 1. Is it? Just ask yourselves, is it greater than 1? Therefore, the exit status is 0. That's fine. But if it's not 2 greater than 1, if it's the other way around, that 2 is less, that 2 is, I clicked on it, there we go. That 2 is lesser than 1, if we put it in like this, the code will still run without any problems, but it will say that the exit status is 1. Remember, we get the exit status from the last function, from the last command you called. And obviously, this is the last one. Echo is just printing it out. Of course, if the echo is wrong, then you're going to get an error as well if you do something wrong in the echo command. Anyway, you can also do this. 2 minus 2
And if you run it, it's going to say exit status is 0. Oops, it's not 2 minus 2, it's 2 minus 1. So 2 minus 2. And it says exit status is 1. What else can we do? We can actually use addition as well. So addition. There we go. And it says exit status is 0. So 2 plus 2 is 4. It's a non-zero value. Then the exit is 0, meaning true. But if it's like 0, then the exit code is 1. So if it's false. Hope you got that. In general, you're evaluating this statement here. Is it true or is it false? It's easy enough to evaluate it with, let's say, a 2 is greater than 1. That is obviously true. Or 2 lesser than 1. That is obviously false. But 2 minus 2 is 0. And the exit status will be 1, meaning false. And 2 plus 2 is 4, which is greater than 0 and non-zero, meaning that not greater. Don't need to look at it like that. Just 2 plus 2 is 4, therefore the exit status is 0. The expression is true. That is how these arithmetic expressions are evaluated in terms of true, and false, as they can be posed as conditions. Anyway, we could have easily replaced these with variables and then just referenced them here without any problems of whatsoever. Now, working with files requires the use of file test operators in conditional statements. I've just mentioned one, -e. It will return true if the file exists. You have a few more. Let's just have a look at them. I will have some examples for you down below. But you have -f, which basically returns true if file is a regular file, not a directory or a device file. So you can check what sort of a file something is. -s, it returns true if file is not 0 size. So, if there is something in it. Then we have -r, which will return true if the user is running the test, if the user running the test has the permission to read the file. So it will return true if the user has the permission to read the file. If it can be read, in essence. If you can read it, it will return true. If you cannot read it, it will return false. -x is the next one. Some of them we've already mentioned before and we've actually used them. -x, it will return true if the user that is running the test has the permission to execute the file. And we of course have -w. It will return true if the user that is running the test has the permission to write to the file. And of course we have the last one that I'm going to mention here, which is the exclamation mark. It doesn't require a dash, just an exclamation mark. It basically just reverses the result of a file test operator. So just puts it in reverse. That's all that there is to it. Now we have these exit status codes. We have E underline, or just do this one first. Actually we use this one. Number of args equals 2. That's just a variable, no big deal. That's the number of arguments needed. And down below we can type in E underline no args equals 65. E underline bad args equals 85. E underline unreadable equals 86. E underline no file equals
87, and E underline size shall equal 89. So the first one means that the exit status if no arguments are given. Second one is exit status if incorrect number of arguments is passed. Most of them you can imply from the name what they mean. And the third one is the exit status if basically you're unable to read the file. Whoever is executing the script is unable to read the file. The fourth one, if the file does not exist. And the fifth one is the status if file is not a regular file. The last one is just status if file is 0 in size. So some of them you can conclude, but some of them, like bad args and size, it's kind of difficult to just conclude from the name. You sort of had an idea of what it is, but you know you cannot just come around and conclude it. Maybe you can, I don't know. If you can, that's great for you. Anyway, running short on time as usual, so I will just go ahead and continue in the follow-up tutorial. Welcome back all. Today's topic will be variables, and we have mentioned them already, but today I will expand upon the subject. Now thus far I have mentioned that there are local and environmental variables. Today I will introduce built-in variables. So these affect the behavior of Bash script, and each one of them has its purpose and meaning. So let's go ahead and see how that actually works out. There are a lot of them. I mean, like really, there are a lot of them. So let's go ahead and start picking them one at a time, although of course we'll no likelihood not mention all of them here, as there are quite a good amount. If I type in echo $, bash, this will give me a path to the bash binaries. Now there are other ones, for example bash underline environment. Now this will hold the location that will be sourced once the script is invoked, but we're not going to get anything now. This is used within the scripts. Anyway, we have $bash underline subshell. Now of this I will talk a good deal later on when we get to the advanced stages, when we actually get to the subshells, but I just wanted to tell you that it does indeed exist. On the more interesting side, you have the bash PID, the $sign. The bash PID, this is the process ID of the current instance of bash, and the $sign will give you basically will give you the process ID of the script. So $sign is the process ID of the script. So let's go ahead and see how that actually works. If we type in echo out, if we want to echo out the process ID of the current script, we shall type in simply $sign. Let's put it in the quote marks, and let's go ahead and run it. So you see 3035. If you're not sure what a PID is, what does it mean? That is the process ID, the identifier for a certain process, so that it can be referenced by something. For example, if I type in htop, I will get a list of processes, and the first line will be PID, process ID, and you can see that every single process has a ID by which it can be referenced, which can be used to actually kill the process or interact with the process in some other way or manner. If you don't have htop installed, you can use simply top. You can still see the process ID on the left side, and you can see the process IDs of every single process that is running. To install htop, just type in dnf install htop --y. That should install it. Okay, let's go ahead and clear this. Bring this down here, and let us go ahead and move on. So another variable which is kind of more on the practical side of things, which you should know, is you can type in echo, and we can echo out the bash version. So bash underline version. And you can see it does indeed issue out the bash version. It's 4.3.42, and then you have this one here, and then release. Now we can basically use an array, which is bash verse info, and I will show you how that works. That is an array of 6 elements that store more detailed information about the installed version of bash. So let's go ahead and take a look at this example and see how that actually works out. Didn't type it in here, but I will show you in the example. So let's go ahead and create a simple for loop, and we will iterate through n. We shall say in, go ahead and open curly brackets from 0 ... to 5. Why from 0 to 5? I said 6 elements. Well, 0, 1, 2, 3, 4, 5. That's 6 elements. We're just beginning with 0, not with 1. The argument list is from 0 to 5. I hope that you can figure that out from the example. Anyway, let's go ahead and type in do, echo out, bash info. Let's go ahead and do this, $n, close it, equals $, curly brackets, bash info, bracket, $n, close bracket, close curly bracket, done. So no big deal. But an error, not too difficult, but because you can see I'm making some errors here and there. Let's go ahead and close it, write it, and let's go ahead and type in first. Excellent. So we'll need a bit of a bigger screen here. And as you can see, this is going to give us a lot more information as opposed to what we were getting thus far with a simple command of a bash version, with the simple variable of bash version. The first one, where it says 4, this is the number of the major version. The second one is the number of the minor version. 42 is the patch level. 1 is the build version. Release, the release status, so just the status of the release. And down below we have x86-64, Red Hat, Linux, GNU. This is the architecture for which it is meant. Since if you're wondering why is it Red Hat here, well, we are using Fedora, or I am using Fedora. For you, this output might be different if you're using, for example, Ubuntu or Arch or something like that, or Mint. Completely relevant, but that is it is relevant that it is different, but the information can come quite in handy. If you're wondering, as I said, why is it Red Hat here, since we're using Fedora, Fedora is basically a Red Hat sponsored project. It's basically the testing ground for all the technologies which are later on to be employed, which are later on to be integrated in Red Hat. So they are integrated in Fedora, and you can see how it works. And then if it works out well, great, it's going to be integrated into Red Hat. If not, oh well, it won't. That's why Fedora is generally not for the absolute beginners, unless you have some sort of guidance. Unless you have some sort of help, you would usually choose Ubuntu or something like that, because you encounter a lot of errors here and there, and it takes up quite a bit of time, and more importantly, it takes a lot of nerves to actually start fixing things. These are usually easy fixes that can be done in 2-3 seconds, but if you're just beginning, you don't know that, so you have to go search through the forums, ask people, etc. to get about things. Anyway, now you might be wondering, why on earth have you recommended us to use Fedora if things are such? Well, I'm using it, and I'm guiding you through it. And if you have problems, you can always go into the discussion section. We're more than happy to help you out any way we can. Moving onwards, we have some more variables like $path, which holds the path to binaries.
It is a list of directories which are separated by colons. Let's give it here's an example. So if it's like echo path, and there you go. So this is one path, colon, another path, colon, another path, etc. It goes on and on. Just keep in mind that the $sign path does not hold the path built-in variable does not hold the current working directory due to some security reasons. You will also have other variables which we will use in the scripts themselves, which is cd path. It's not going to output anything now. This holds a list of search paths that are available to the cd command. Paths will also be separated by a colon, and then you have a dot s, then you have $sign and editor, which is the default editor that a script invokes. Now, you also have the UID, which is the user's real ID number as recorded in etcpasswd. This is read-only variable and cannot be changed. So if we type in echo $UID, you can see that the user ID of the user Kreponic is 1000. And then you have the EUID, like this. They can be the same, but they do not have to be the same. EUID is the effective user ID. It's the ID number of the user's current identity. As I said, it can be the same as the UID, but it doesn't have to be necessarily the case. Let's go ahead and take a look at one of the examples and see how this actually works out. Let's just go ahead and delete this. Root underline UID. So by default, root has the UID of 0. This is something that you should know, quite important, and pretty easy to remember. Root has the UID of 0 by default. Let's go ahead and echo -n UR colon. Now, and just doesn't print the trailing new line character. What does that mean? Well, the next echo below will actually not go into the new line, but rather instead it will go into the same line here. Okay, so let's type in if space bracket $UID, and we can have something like dash equal quote marks $root underline UID quote mark, close it. Then, so this will basically check if the user ID is the same as root. And we shall echo out root, which will tie to the upper statement of echo, dot your, notice the escape character that I'm using for the $sign. UID is equal to $UID, and here I'm actually referencing the variable itself. Next up, we'll type in else echo user. So you are some user. Your UID is equal to $UID. Finish. Let's go ahead and write this, and let's go ahead and run the script. You see, you are user. Your, and then the $UID, I just want to show you which variable is being referenced here, is 1000. And see how it actually prints it out. You see here, I've echoed it out, and still it comes out. So this is the, there we go. So UID, this is EUID. As I said, can be the same, but it's not
mandatory. If I was root, it would have actually printed out you are root. Simple as that. So no big deal. Next up, we can go ahead and take a look at the variables which actually contain the function's name. I haven't really mentioned the functions, and that's going to come, but here's a bit of a sample that I'm going to go ahead and show you. For example, if I'm writing some function, and if I type in, I don't know, some function. Okay, I'm not going to give it any arguments. Functions will be explained I will explain them in great detail so that you understand them. But here, I'm just going to go ahead and call a simple function. I'm going to create a simple function, and then I'm going to call it, which will do the following. So echo out. Function name is name. Oops. And let's go ahead and call the function. Some function. Okay, so down below, this will call the function, but we can type in echo down below just to demonstrate one more point. So outside, I will explain soon enough. So name equals name. Okay, so we have created a function here. Inside that function, we have stated that we would like to echo out the function name. This is the function name. And now we have called the function, and down below the function, we are actually again printing out the variable for function name. But here it will actually be null because it is outside of the function. So let's go ahead and see how that works out. Press enter, and you see function name is some function, yes, and then it says outside. I've just stated outside so that you referencing to the fact that it's actually outside of the function, and we want to write this variable out here, and then we want to write its value out, but no, the value is null, non-existent, because it is outside of the function. This will only print out the function name of the function in which it actually is. If it's outside of the function, not gonna happen, not meant for that. Anyway, running short on time, bid you farewell, and we will continue with this in the follow-up tutorial. Welcome back all. Today's topic will be loops, and this will be a sort of a mini chapter. I have already shown you some of them and how to use them. Basically, I needed to because some other concepts were rather difficult to demonstrate without loops. They're basically constructs that repeat some sort of actions for a certain number of iterations. That number of iterations is usually defined with some sort of a condition, and as long as that condition is true, loop will continue to iterate through the list of commands and execute them. We have three different loop constructs in Bash. That is the for loop, while loop, and until loop. The last one I didn't show you actually. I don't believe that I showed it to you anywhere, but don't worry, we will go over it here. So we will go through each of these actually and describe how to use them. Also, I will talk about how to control loops using break and continue commands, and in the end, I need to also go through case and select constructs, which are not actually loops, but they still do control the flow of command execution. Now, some of the things I will skip a little bit because I don't feel like repeating myself over and over, and I'm sure that you don't want me to do so either. Anyway, in regard to the for loop, what I wanted to demonstrate here is a nested form of a for loop. This is a fairly common concept to use and a quite a necessary one. So if I type in, for example, for I in 1, 2, 3, 4, and 5, do echo out outer loop, and let's go ahead and use this one. This will be the number of iterations, and I would like it to stick out, so I'm just gonna place a bunch of dashes here, and done. But within this loop, I can go ahead and create yet another one. I can type in for j in 1, 2, 3, and again we shall write do go out inner loop dash j. Done. And also I would like to make another point here, which will be, how shall we mark this one? Let's go ahead and like outer loop iteration dash I. Excellent. So now we have two loops, and at this point of time, if possible at all, it wouldn't be a bad idea for you to actually pause the tutorial and think about what sort of an output will you get on the screen. So how will this actually play out? What will you get from this? How will this execute? Will it execute one iteration of this loop and then one iteration of this loop and then go around? Or will it execute one iteration of this loop and all the iterations of this loop for this many times? Just, if you want, feel free to pause the tutorial and think about it. Don't look it up on the net immediately. Just try to think about it and to figure it out, to visualize it. If you fail or make an error, or if you don't do it, it's perfectly fine. I'm going to go ahead and explain it to you anyway, so just sit back and relax. Let's go ahead and run it and see what happens. And as you can see, it goes through the for loop first, the outer one that is, and it says outer loop, first iteration, and then these dashes that I've placed here. Okay. And then it goes into the inner loop, and it goes 1, 2, 3, so through all 3 iterations, and it says outer loop iteration 1. So the I does not change values while this is actually running. It can if we specify it, but yeah, that's a subject for another day. However, you see, this is printed out. This for loop has to be finished before machine can actually exit out of it and go back into the outer one. Then the outer one runs again, as you can see, outer loop, iteration number 2. And then we go back into the inner one, complete the inner one to the fullest of extents, and then we go back to the outer. And then again, 1, 2, 3. And then the outer ones, and then the inner 1, 2, 3, and so on and so forth, in a repeating pattern of a sort. Those are one of the things that I wanted to really demonstrate here, and how you can actually pass the variables to the for loop in terms of creating the outer, the inner, and you can nest them on pretty much on end. As I said, this is an important concept. Keep it in mind. You will, if you ever plan on using Bash, and I'm guessing that you are because you're looking at this tutorial, nested loops will be indispensable to you. Okay, so in the follow-up tutorial, we will go over the while loop. I've decided to separate them like this instead of making one lengthier video encompassing pretty much everything. Rather, instead, I shall just split them up one by one. I do believe that it will be better organized in such a fashion. Okay, so welcome to another mini chapter. In this one in particular, I intend to cover internal commands and some other built-ins as well. Here, the commands that I will talk about here, they will deal with input-output, file system. Some of the commands will be used with variables. Others, on the other hand, will be used in order to control script behavior, and something that's a bit new, that's, I wouldn't say completely new, but definitely that I really haven't talked about until this point of time. There are commands that are used in job controls. What these are,
In particular, you will see, I know the name sounds a bit strange and weird, but believe me, they are useful. All of them are pretty much hard-coded into Bash. Well, this can be good in terms of performance, but there are some other issues in terms of programming and in terms of access that are responsible, that are the cause of these commands, being created, let's put it so. I won't go into those issues. Whole books have been written on such subjects. Anyway, the very first group that I intend to cover of the internal commands will be I/O commands. So, these, well, we have already mentioned some of them, haven't we? We have used echo, right? We have used read. But what we have not used thus far is printf. And printf is such a universal way of outputting something onto the screen that you can find it in pretty much any programming language that is in existence today. For example, well, you certainly can find it in C and C++, and you can find it, I don't know, in Java, etc. Pretty much in whichever programming language you can think of, you can pretty much use printf. It's such a universal way of outputting something onto the screen. And what you learn here about printf, you will also be pretty much be able to apply this to, any other programming language. Some of them have different ways of outputting it onto the screen, but printf is still integrated and most people still tend to use printf. For example, C++ has cout, which is, I would say, generally hated, but I really don't want to spawn a debate here, so if you think that cout is better than printf in C++, I don't care. I really don't. I don't want to start a debate there. Anyway, coming back to the subject, let's take a look at our first example. In order for us to create it, let's go ahead and declare a rather unique variable, a variable with a rather unique value, let's put it like that. Declare -r. I would like this to be read-only variable. I wouldn't like its value to be changed. So this will be typing in the value of pi. 314, have it written here. The decimal place is 15926. Okay, I think this should be enough. No need for more. Hopefully you all recognize this value and you all know what pi is. If you don't know what pi is, well, use your favorite search engine and type what is pi. And yes, the internet will answer you. No big deal there. Just a math thing. People generally most countries tend to learn it like in elementary school, so I'm guessing that everybody knows. But the reason why I'm using it is because I can write pretty much as many decimal places as I want. This is only a few of them. They can extend for quite a while. I don't know, online you can find series of 20,000 decimal positions of pi or something like that. I don't know. But in any case, here's what I'm trying to, here's my point. Printf, and printf will allow you to format the output on the screen. It will give you a greater degree of control as opposed to echo. If I type in, I don't know, second decimal of pi is, and here is how I would define how many decimal positions would I like to be printed out onto the screen. And in general, these decimal positions, numbers with these decimal positions like 0 point something or stuff like that, those are usually referred to as floating point numbers. I do believe that I have mentioned them briefly before. If I type in percentage sign, never mind the one, like forget about it says 1 point something. You can say 1.3 and then F, and then this will, what we have, second, right? It's not the third, it's the second. So this, what we have written here, will now reflect itself onto a variable outside of these quotation marks. Fine. Right? Right, and there you go. It says second decimal of pi is 314, but this is such an ugly output. Let's go ahead and insert a new line. How would we insert a new line? Well, \n within the quotation marks will insert a new line character without any problems or without any extra arguments passed to the printf command itself. And there you go. It says second decimal of pi is 314. Let's say you would want some other decimal. Let's say you would want the fifth one. No problems. Just type in 5-1 and let's change this. Fifth. There we go. It says fifth decimal of pi is 3.14159. Pretty simple, right? No big deal. You format the output within the quotation marks here, and then it reflects onto variables here, or this variable in particular. So that is how we would be able to define like how many decimal places would be like to be printed out onto the screen. Okay, so I'm gonna cut it here, and then we will move on. Then I'll say a few more words about read, some of the things which we haven't actually done thus far. Welcome back, all. Today we shall dwell on the subject of regular expressions. We would define these expressions as a string of characters. Characters themselves are categorized onto those that have literal meaning, and meta characters. They are those characters that have another meaning besides the literal one. Characters retaining their literal meaning together with anchors and modifiers, they form regular expressions. The very purpose of a regular expression is to search text and manipulate strings. Now, this we have done. We have used grep before to pull out certain words out of certain texts, or out of the files, or out of the standard output, or something like that. Anyway, we have seen many commands in the past tutorials that use regular expressions. For the grep, which I've just mentioned, sed, especially, and awk. We will take a look at the following example and see how grep command uses expressions to solve a crossword puzzle. I figured this would be a bit of a more complex example, and we would see how grep would function in this manner. Okay, so let's have a look. Let's first of all define an exit status if no pattern is passed. We will type E, underline, no pattern equals 71. And we will state that we will declare a variable which will be some sort of a directory. dict equals usr share dict slash linux.words. Okay, so this is where we shall look for certain words. And below, let's go ahead and make an if statement. Anyway, if bracket ups dash set $1 close bracket, there we go. And then, so this will basically check if any parameter is passed. So if no parameter is passed, this will be evaluated to false, and if a parameter is passed, this will be evaluated to true. We have mentioned -z before, and we have mentioned what $1 represents. If you have skipped the tutorials, please go back or post a question in the discussion section. Somebody will be there to help you out. And then let's go ahead and type a long echo, so to say. So just one line, one empty line, then echo usage, echo, base name, $0. Hopefully you know what $0 means. Backslash pattern, comma, backslash, let's just go ahead, use another quotation mark, and then close the quote marks. Now I have made a bit of a mistake here.
I didn't put the closing on the back quotes. Doesn't really matter. Let's go down below, echo where backslash pattern. By the way, you should know what this means, what these symbols mean. Backslash, quotation marks, backslash, quotation marks. We want to print the quotation marks in the output of the echo itself. That's why we're using these escape chars, so that they would be printed out. Is in the form echo, I don't know, oops, not zeros, dot dot, dot. You don't need to place the dots as I have placed them, no worries. Echo the O's, let's put it like this, are letters you will already know. Let's put a comma. Let's go into the next line. Echo, I know it's a bit of an elaborate echo statement, but yeah. And periods are missing letters. Oops. Echo letters and periods can be in any position. I am checking my spelling. If I make an error somewhere in terms of spelling, please don't hang me. I would be very grateful for that, but feel free to direct my attention to it. Example, and W to let's say 3, and then 1, 2, 3, 4. And you don't need the exact same amount of dots as me. And then let's go ahead and type in echo for one empty line. Exit. The exit status will be E underline no pattern exits. Yeah. And let's go ahead and finish this. Alright, yep. There we go. No pattern. I need a double T there. It's so wonderful to spell these things. So anyway, so why this and why this exit statement? Well, if no parameter is passed and if this evaluates the true, meaning that no parameter has been passed, well, you're gonna type in the usage, how it is used, and you will explain a few other things, and then you will basically have an exit status 71, meaning that no parameters have been passed to the script. Otherwise, grep and let's oh god, grep, let's use a caret sign, quotes, $1, and then we shall use another $sign, so $sign DICT, close quotes. Okay, now the caret sign here, this is an anchor that matches the beginning of the line. The $sign here is the anchor that matches the end of the line. Grep searches for a pattern in this variable, which is basically a path to this file. And now we will see how it actually works, what happens and how it actually goes. So if I run it, oh wait, I didn't pass any parameters. What did I get? Oops. Usage first.sh pattern, where pattern is in the form of tra-la-la. The O's are letters you already know, and the periods are missing letters. Okay, so let's give it that particular pattern. First.sh, let's pass it some sort of an English word. And what would that word be? I don't know. Wood. W-O. And how would we specify the letters that we don't know? We'll just take a look at it here. The O's are the letters you already know. Okay, so these are the letters that I know. letters and periods can be in any position. Example, and the periods, there you go. So just look at this part, and the periods are missing letters. So there are some letters that you don't know. So WO dot D. Hey, look at this. I have no idea what this is, or this, but I know that this is wood, and I know that this is word. If anybody knows the meaning of these words, well, feel free to enlighten me. But it doesn't matter. You see, this is you have the words here listed in the English dictionary, and we are using this script to pull certain patterns out of here. It's a good place to pull patterns out because you have a lot of words, so you can pull pretty much whatever you want. Let's try a more complex word, which is wait, I'll think of something. Building. And let's go ahead and place a dot here and a dot here, and we can place 2 dots here. Hey, what do you know? It actually pulled that exact word out without us knowing all the letters. But let's do something stupid. Let's do this. So what? We have everything that starts with B and has 2 additional letters or some sort of symbols. Oh my god, there's like a lot of them. Is there a but here? So I'm looking for BU. BU. There we go. So but is here, or by below. Here, if I just add Y at the end, you see bay. I think this is a title, boy, and by. So there you go. This would be a very simple way, a very simple script which would pull certain words out of the dictionary in Linux. Anyway, I bid you farewell, and I hope to see you in the follow-up tutorial. Welcome all. The topic of today's mini chapter will be I/O redirection, so input-output redirection. What is it? We have used it thus far, but I haven't really explained it extensively. Redirection is taking the output from some sort of a file, script, or a command and redirecting it as input to another file, script, or again, command. Files that are always open by default are std_in. This is the keyboard input. std_out. This is the output on the screen, and std_err. This is the error message output on the screen. Each of these files are assigned some sort of a file descriptor, so 0 for std_in, 1 for std_out, and 2 for std_err. std_in is standard input, std_out is standard output, and std_err is the standard error. File descriptors for additional files, they range from 3 to 9, and sometimes it can be a good idea to assign one of these descriptors to std_in, out, and err in order to serve as some sort of a temporary duplicate link, but we're going to go ahead and skip that for now. So let's go ahead and take a look at some examples. Let's go to our script and type in file equals wood.txt, because that's the file that I have, and I'm too lazy to rename it in any fashion or way. Echo, this line is sent to file 1 file. Is it? Yeah. Anyway, so what do we have here? What is this? 1 greater than. Well, we have a file here to which we direct something, and we will redirect the standard output to this file. Basically, the standard output of echo is whatever we write here. This is sent to this file, and then all this entire line that is printed out onto the screen usually will no longer be printed out onto the screen, but rather instead it will be pushed into this file. So this is just the simple redirection of standard output. Let's go ahead and run this. Oh, by the way, just to prove that I don't have anything in wood of significance. You see, it's just tralala test, whatever. But now when I run the script, and when I cat out wood, it says this line is sent to wood.txt. This line is sent, and then we have a file name here, which is wood.txt. Just readjusting myself in my seat. Anyway, to redirect a standard error to a file name, you would do the following thing. But let's go ahead and use this in a bash, just in a terminal. If I just type in something on the command line and press enter, it's going to say bash something, command not found, an error message. So if I would like to redirect this error message, I can type in 2 greater than, and let's redirect it to a file, wood.txt. Cat wood.txt. And excellent, it says this line is sent to wood.txt, but down below it says bash something command not found. Why is this added? Well, if you remember in the previous tutorials, I mentioned that when adding 2 greater than signs, you are appending the file. You're not actually substituting what is already in it. But the standard error was redirected. Now, there are some strange cases where you would redirect standard error to standard output. How would you do that? Well, it would do something like this. Oops, let's clean the screen first. Clear the screen. Greater than wood.txt space 2 greater than ampersand sign 1. But wood.txt already exists. Let's just name it wood1.txt. So this will create this particular file, and then it will redirect the standard error to standard output. Let's press enter and see what happens. Nothing. There is no error. If I type in ls wood1.txt, it will indeed list it there. It exists. It has been created. If I just type in this, you will see that there is nothing in it. It is completely empty. But we didn't have any problems there at all. That was just, it created it and the redirection was done, but there wasn't just anything to redirect. However, down below, if we type in something, as in a non-existent command, and if we redirect, and if we do a redirection here, wood1.txt, and then we're gonna do 2 greater than ampersand sign 1. This will append both standard output and standard error to basically wood1.txt. Let's see what happens here. Cat wood1.txt. There you go. You see, standard error was redirected. So both standard output and standard error were redirected basically to this particular file, and as you can see, this is what we have here. There was pretty much no standard output, but you had standard error, which you can read from here. Bash something command not found. I know it's a bit of a strange and weird concept, but I just wanted to run a few of these by you, and some of them more important than the others, but oh well, it's good for you to know them in general. Okay, so let's go ahead and minimize this and go back into our bash script. Let's delete this. So to assign a file descriptor, we will need to do the following. Let's type in echo 1, 2, 3, 4, 5, and then greater than sign. And I don't know, I shall type in fd, meaning file descriptor .txt. It should create the file if it does not exist. And then down below we will type in exec, and now we shall have to type in something weird like this: 3 lesser than greater than fd.txt. So this will basically open up the file, the specified file, and assign a file descriptor 3 to it. Now let's go ahead and enter and go into read -n2 lesser than and %3. This will read only 2 characters, if you remember from the previous tutorials, from a particular file. So let's go ahead and see how that works out. Next up, we will type in echo space -n space dot space greater than and %3. Down below exec 3 greater than and %, and now we have a minus. Excellent. So down below, let's just see what became of all of this. Cat fd.txt. So echo -n dot greater than and %3. This just means that it will write a decimal point there. And down below exec, it means that it will close the file descriptor 3, and then it will actually list the lines of the file descriptor file, and that's pretty much it. So it should print out something like this. Okay, so we have problems. Let's go ahead and see what they are. Okay, read n option requires an argument, and I am missing something here. Let me just see what it is. -2 and right. I need a space. Sorry for the confusion. No big deal. We all make errors. As long as you can find them and correct them, that's nice. So just a small space here was a problem. Let's go ahead and run it. Excellent. So it says 1245. I know, this is a bit weird, but we have specified such parameters here. So let's just go over them one more time. I know that this can sometimes be a little bit confusing. So first, we write 1, 2, 3, 4, 5 into a file called fd.txt. So we echo out and we redirect the standard output into fd.txt. What we do next, it doesn't matter. What we do next here is open the fd.txt and assign a file descriptor. We assign a file descriptor 3 to it. Next, we read only 2 characters from the file with this command here. And then we write a decimal point there. Afterwards, we close the fd3, and then we will list the lines of fd.txt, and that's pretty much it, with meaning 12.45, meaning 12, and then instead of 3 we have 45, as we have formatted the output in such a way. So I went one line over one line. I've demonstrated to you the output. If I know that this can be a bit confusing, believe me, I know, I feel it. Sometimes I get confused with these things as well. Please feel free to visit the discussion section. That is why it is there, to help you as much as we can in order to understand this. Anyway, I bid you farewell, and I shall see you in the follow-up tutorial. Welcome back all. Today I shall open up a new chapter on functions. Now this is, I would argue that this is one of the most important chapters for you to learn. Functions are something that you will commonly write, and the general logic of a function remains pretty much the same and relatively unchanged from one programming language to another. So syntax for writing a function in Bash is following. It's pretty much the same anywhere else. We type in some function name, then you would type in these parentheses, and down below curly bracket open, closed, and some set of commands. Anyway, Functions here can be also written in one line. So all of this can be placed into a single line, but there is a trick. So if it's on the single line, it needs to be, all the commands need to be separated by a semicolon. So command 1, command 2, etc. and so on. They can be written on the same line. Semicolon must follow every and each one of them, and the last one as well. To call a function somewhere within the code is fairly simple. So function can be simply called, or function can be called and parameters can be passed to it if the function is so written that it requires parameters. So let's say, I don't know, some code is here, and down below we would like to call the function and use it. So we just type in the name. If you would need to pass some parameters to it, well, just pass them in a normal fashion. par1, par2, par3, and so on and so forth. So parameter 1, parameter 2, parameter 3. Keep in mind that the function must be defined before it can be called. Failing to do this will result in an error. However, it is possible to have a function calling another function that has not been defined. This should not be a problem if the call to the first function happens after defining the second one. Strange, I know. Let's have a look. Let's see how this works in practice. So function 1, let's have a look. Okay, so normally these things would be written here, like this, to save a line or two in writing the code. I don't really like to write it like that. I like to put it here and then actually write it. It's just a matter of style and preference. You can do whatever you wish in that regard. So call F1, we'll just name that function 1, or F2 like function 2. And then let's use these escape chars to have quote marks from F1. Okay, so let's just finish this. Dot is there for aesthetic reasons. Okay, so now we can say function 2. And down below, we can type in function 2. I'm just naming them like this. These are generic names. Names of the functions can be rather strange. I'll show you in a moment. Okay. Echo. I don't know. This is F2. We can put some quote marks to make it a bit prettier. There we go. And down below we will type in function 1. So we have defined a function here, function 1 here, and we have defined the function 2 here, but we have called the function 2 before it was defined, and that can be a bit of a weird situation. So we are calling we're gonna go ahead and call the first function down below, and the output should actually echo out this as well. Let's see what happens. Should work. There you go. Call F2 from F1, and there you go. It says this is F2. Let's go and talk a bit about more abstract subject. Functions cannot be empty. However, it can contain a null command and thus won't result in an error. Let's have a look. So you cannot leave the function empty. This is not something that is permitted. If I just save this, I mean, it can be illogical. You see, it reports an error. So there is a syntax error. Something is expected. It's not supposed to work like this. But if I put the null character in, which is the colon, and if I run it, See, nothing happens. There is no error. The function has been properly declared. There are no problems. There can also be nested functions. However, the usefulness of this is questionable. Also, you should be careful when calling nested functions because they need to be called in the order in which they were nested. So if we have function 1 and if I type in function 2 and if I type in echo, this is nested function. I will also need these curly brackets here. There we go. Down below, the order in which they can be called is following. So function 1 and then function 2. Let's go ahead and write this. Basically, it should output the same thing twice. Oh, sorry, no, not the same thing twice. The first function doesn't actually do anything. This is nested. This is a nested function. I missed the A sign there, misspelled that. But anyway, they need to be called in this particular order. They cannot be called in any other order. Calling in the order functions were. I mean, if we were to call function 5, this would result in some sort of a problem and some sort of an error. So let me just show you. Sorry, not function 5, function 2. It's arranged a little bit differently in my notes on the side. Let's go ahead and run it, and you can see it immediately issues out an error because we haven't called function 1 first, so this can be a problem. Functions names can have some really strange forms. I mean, to the point of absolute madness, I would dare say. Let me go ahead and show you what I mean by it. Okay, now that this is deleted. You see here it says function 1. Seems normal, right? Everything seems to be fine. Get this. Underline. Yeah. But there is no space between the underline and the parentheses, so that's a bit of a new thing and a bit weird. So let's go ahead and type in something like echo, hey there, I am, and then we shall echo out function name. I've shown you what this is. Fun name, and there we go. Oops, close it. Let's go ahead and run it. It doesn't do anything. Why doesn't it do anything? Well, I haven't called it. I haven't called the function anywhere. So let's go ahead and call it. How shall we call it? Well, just type the underline. That's the name of the function. You see, hi there, I am underline. Yes, I know. You should really experiment with these names just to see what will actually pass and what won't. But a lot of things will, and you will see that they can have some really strange and some really messed up names. Next up, as I have mentioned previously, arguments can be passed to functions. Functions process these arguments by position. That's the $1, $2. You know, like the arguments are processed by our scripts, which we pass to them. So let's go ahead and see how this actually works. Actually, you know what? Let's leave this function name. Let's just leave it. And here it will, here it will state echo, and the first arg is $1, comma, second arg is $2. Excellent. So var1 shall be equal to 10 var2 shall be equal to 20. And then when this function is called, we shall type in var1, var2. So remember, underline is the function name. Let's go ahead and save this, and now let's go ahead and run it. It says first arg is var1, second arg is var2. Keep in mind that if a function expects parameters and the call to the function does not provide any parameters, then the function treats the parameters as if they were null values. Can be a little bit confusing at times. So one needs to be really careful with those things. Also, a function can take a command line argument passed to the script as parameters, but they still need to be passed to the function just like regular parameters do. Let me just go ahead and show you an example of this. Instead of var1 and var2, I can type in $1, $2. I'll just leave var1 and var2. There's really no legitimate reason to delete them. If I run this, first arg is, second arg is, you see they are treated as null, so there's nothing there. But if I run this like 10, 20, first arg is 10, second arg is 20. See? Fairly simple. No big deal. Anyway, I will cut the tutorial here and I'll see you in part 2. Welcome back. So today I am going to go ahead and begin talking about arrays. They are a common thing to be used in Bash and pretty much any other programming language out there. But you might notice that there is something different on my screen. There is a number 1 right on just before the first line begins, just before the first line of code. So if I press enter, 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 you see how my lines are numbered. Now this you can do by pressing escape, set number, or escape, set no number. Basically, you either want your lines to be numbered or you do not want your lines to be numbered. By the way, when you press colon like this, you can actually rotate between commands. So I would like to set the number. Also, you can specify the range of lines which are to be deleted, and in this manner you can clear the file of a script. So if I do, for example, this 2,4D, that will delete everything in between 2 and 4. See, it just shortens the line, so it says 3 fewer lines. Or I can basically go ahead and specify the line from which I want to begin, and then state with a $sign to go to the end, and then use D as the delete command. There you go, I am now on a single line. Excellent. So now that we have that, it should make our code a bit more readable, as we are slowly starting to move into bigger and bigger scripts. So let's go ahead and take a look at the syntax of an array. If you type in var, and if you put brackets like this, and you can type in value here, basically this would be an array. Let's see that in practice. Let's see how that is used. So if I type in, I don't know, our just var r array, and if I do this, if I say 0, meaning the first element, equals to 20, that means that the very first element of the array is equal to 20. Okay, and if I go ahead and say r1 is equal to 30, that means that the second element in the array is equal to 30 because the counting starts from 0. That's how the indexing works, so that the value of the first element is 20 and then the value of the second element is 30. Let's go ahead and type in echo. We're gonna need a dash E for this. R0. Well, let's just cut it short and put it like this. R, and then the 0. Yep, there we go. So let that be the first one. And we would like to go into the new line. And on the new line, we will print out the second one, meaning like this. R1. There we go. Let's just close the quote marks. Write this, and let's go ahead and execute it. So you see that the first one is 20 and the second one is 30. We can modify the script a little bit like this, so we don't have this extra space down below. There you go. So it says 20 and 30. It's giving you the values of the first element and of the second element. I'll just balance this out. There we go. Also, array can be declared using a declare command, what we have seen before. So just as we have used it for other variables, you can go ahead and use it for this one as well. So declare and -a would stand for array, and R like this. I'm just using the name ARR as an array, but you can use pretty much whatever you want and name your variable. So now name your array. So now we have declared an array. The -a stands for array. Now we need to initialize the array. In order to do this, we need to go ahead and do this below. Type in ARR, which is the array that we have just declared, equals, and then just open up parentheses and type in the elements in the order. So it's going to go from the element 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, 10, 11, 12, doesn't matter. So we can type in, I don't know, 10, 20, 30, 40, 50, 60. Let's leave it at that. We do not need any more. And those would be now the elements. If you type in, we can just go ahead and copy paste this. Oops, sorry. We can go ahead and copy paste this like Control Shift C. And let's just go into the new line. New line. And again, new line. We don't need to print them all out, but hey. So let this be the element 2, this can be element 3, and this can be the element 4. Let's run this. As you can see, it will be 1, 10, 20, 30, 40, 50. All of them are declared. Fairly simple. Another way of assigning elements to an array basically be the following. If you just delete this first. There we go. Type in ARR equals so let the first element, how shall we initialize this one? We can say first, and then we can say it's equals second. These will be strings. And I don't know, let's put it like this. And so 0, you don't need to initialize them in this particular order. Now you can initialize the 7th element of the array and state that you wish it to be equal to, let's say 45. Doesn't really matter. So let's go ahead and close the parentheses. And now we can go ahead and print this out. So we need these. These are not initialized, so we don't really need them. We just need 3 of them. This will be the 7th one. Okay, so let's run it. And you say it says first, second, and then it says 45. No big deal. Should be fairly simple. Now it should be noted that Bash does allow array operations on variables. However, keep in mind that array is then seen as an array of one single element. Let's go ahead and take a look at what is it exactly that I've just stated here. if I go ahead and delete this, I'm just going to leave A for the sake of simplicity, and I'm going to say that this equals to something 1, 2, 3. Now we shall echo out these, which is a pretty painstaking process to write this, but okay, no big deal. Probably should have copy-pasted it. I should have copy-pasted it because I'm doing the demo, but you should write it down so that you could remember better, as I have explained in the previous tutorials. Okay, so A shall be 0. Now you will see what these particular things will mean in a moment, but try to guess. Try to go in front of me. Don't be on par in terms of following me. Try to be a step ahead of me. In my opinion, that's one of the best ways to learn. However, it doesn't necessarily need to be, as I've just said. That's just my opinion. Okay, so A and F. Excellent. So now we are echoing out all these strange things. What on earth could they mean? Well, first of all, A is assigned a string, something 1, 2, 3. Now, this asterisk, what does it stand for usually? Isn't it a wildcard that stands for everything, like a joker in cards? Yes. This will list out all the elements of the array. So all of them will be listed out. S, O, M, E, T, H, I, and G's. I know that this is just a variable and this is a string that is assigned to it, but it can be treated as an array. The next one, S0, well, this will list the first element of the array, which is S. That's what's going to be printed out to the screen. 1, again, this will list the second element of the array. And what do you think will be the difference between these two? Well, unlike the wildcard character, which actually takes this entire thing, doesn't actually take them one by one, that was a bit of an error on my end, which takes this whole thing and prints it out onto the screen. 0 will also take the whole thing and print it out to the screen because this is considered to be the first element, and A, which says 1, that is considered to be the second element, which is non-existent. It's not here. And the final one, it will actually print out the size of the array. How many elements are there in the array? How many elements do you think there are? So if 0 prints out one element and if 1 prints nothing, well, there's just one element, as you can see. It's just one string, which is part of it. It's actually just a variable, but we're treating it as an array. Okay, so, well, we are treating it in any case, not the machine. And there you go, it says something 1, 2, 3. Okay, wildcard replaces all, so something 1, 2, 3. Again, something 1, 2, 3 because it's 0. 1 prints out nothing because there is no second element. And the 9th line, which pretty much serves in order to give us the size of the array, well, that prints out 1. It only has one element, nothing else. Bash has adapted some commands and operators to suit array operations, depending on the Bash version, but hopefully you're using the latest one, the one that I'm using as well. And there is no reason why you should use the older ones, really. So let's go ahead and take a look at one of the examples and see what happens. And now we can basically use the delete, so delete everything from the second line basically to the end. There you go. So that was simpler as opposed to just using the backspace. Let's go ahead and type in R equals, this is another way to go ahead and initialize it straight away, make it and initialize it. So how shall we do this? I don't know, 0, 1, 2, 0, 1, 2. I'm keeping it as simple as possible. Echo out, and we shall echo out, go ahead and echo out the first element. So, went a bit messed up my notes, but okay, no big deal. So R, open up brackets, 0, close the curly ones. So as before, this will simply print out the first element, no big deal. Okay, let's try something different. Echo. I'm just showing you different variations of what you can do with an array, how you can get different outputs and information from it. Okay, so let's do a hash R, and this is going to be 0. What will this print out? This will print out the length of the first element. What is the length of the first element? Well, 1, 2, 3, I guess 1, 2, 3, 4. It will print out 4. Okay, so let's go ahead and see another neat option. If we put hash here, R, and if we put a wildcard character here, what do you think that this will print out? Well, this will also print out the size of the array, pretty much. So no big deal. The same as the option which we have used with the @ sign. So I could have placed the @ sign here as well, but no, I placed wildcard character. It also works without any problems. And as you can see, the first element printed out 0. The size of the first element is 4, and the size of the array is 3, as you do indeed have 3 elements. Fairly simple, no problems there. Anyway, I'm going to go ahead and cut the tutorial here, and then we'll continue on in the follow-up. Welcome back all. Today I'll start talking about debugging. So in this particular tutorial, we will cover different methods you can use in order to debug your scripts. Often, when there is a bug in the script, you get an error message that doesn't really help you in understanding where exactly the problem lies. So take a look at this example. Just something simple. For n in 1, 2, 3, 4. Do echo n, and I shall type in exit 0. Now I've deliberately omitted the done at the end, but if I run the script, you see it tells me that there's some sort of problem on line 8, right? So I know that there's a problem, but I can guarantee you it's not on line 8, which is pretty much after the end. The error message points to the line where exit 0 is, which is really not correct. If you type in echo $? It's going to give you the exit status of the script, and the exit status is 2. This is a reserved exit code and means that a keyword or certain command is missing, which is basically true, because in our example we're obviously missing the done keyword at the end of the for loop. So that is what I mean. That is just a fraction of what I plan to cover in regard to debugging. So you need to be able to figure out where the mistake is occurring, where the problem lies. One of the ways in which you can do it is actually to use the line no global variable to give you the line number. If I type in rm abc, I don't know, that's going to be the file that I'm going to remove. And if I type in let line so if you think you're having a problem with a certain command, or if you think that something is going to be problematic, line no minus 1, and down here I'll type in echo rm is on the line, there we go. Anyway, why -1? Well, because line NO will get the current line in which it is located, but we really want the line where RM is. And if I basically run this script, I don't have a file ABC. It will say that it cannot remove the file ABC, no such file or directory. RM is on line 3, so it says RM cannot do something, and then it tells you where RM is in particular. So if you think that certain pieces of the code will be problematic, you can insert these lines. But this is just one of the things that you can do, and not always the most useful of things. Now, you can debug your script by using the option flags, so -n, -v, and -x, in combination with the sh command, but you can also set these options within the script itself. So if I, for example, type sh-n and then and then the script name first.sh, nothing happens. Well, why? Well, because this is checking for syntax error in the specified script, but it doesn't run the script itself. So it doesn't really run the script, but it does check for the syntax errors. Here, let me just see if I can reutilize this previous code. I don't think this is going to work. I'm going to have to write something of my own, but actually it will. So I can save some time there. Look, I basically can inspect the scripts for syntax errors without running the script, which can be quite useful. So without running the script at all, I can check for syntax errors, because sometimes you just can't run the script. Why? Because it was written for one purpose for a certain environment, and you are running it on a completely different machine that has none of the files or the parameters needed, or none of the files or none of the programs perhaps needed for that shell script to run, and you want to check for syntax errors. So how would you do that? Well, sh-n, and you would check it. Next up is the -v. It stands for verbose. So if I basically just do this, I can also do sh-v and then the script name, but I can also do it like this. Set -v. Right? And let's run the script again. So first.sh, line 10, it says syntax error, unexpected, and the file. What does the... Oops, this is n. Sorry. I bet I need... I don't actually need any of this. I just want to run the script. My bad. My apologies. If I run it, you see it actually lists each and every line of code. And it gives me the syntax error message as well. So I can actually see the script that was ran, and I can see the error message on the screen. So this is the verbose mode. It echoes each command before executing it. Can be quite handy. Now, next up, which is sh-x, space -x, it pretty much echoes the output of each command. It first prints the command and then its output. So let's take a look at the example of how this works. Let me just do this. There we go. Back to the insert mode. I shall need a bit of a different example here. This was with the -v, but I would like to use -x. So a equals 3 if, I don't know, $a is greater than 0, then echo $a, and we shall type in fi to finish it. So let's go ahead and write this and type in sh-x first.sh. Excellent. So now we can have a look at this output, but let's go ahead and format it a little bit better. There we go. So just to clear the screen. Now, this particular command will echo the output of each command in the script, the one that we actually ran. There is an error on this line, and this command points to it. So you can actually see what is going on here. It's actually showing you the output. Let me just go ahead and show you. So we can see that we made a mistake by not putting a space. Have you noticed the spaces between opening bracket and the variable? And the variable basically a that we placed here. So there are no spaces here. Look, bracket, no space, no space, and close bracket. This shouldn't be as it is. And of course, this has generated an error which states that the command has not been found. Now let's go ahead and correct the mistake and see how does this actually help us out and how do the outputs differ. So, yep. Let's go ahead and do these. Write it. Okay. They seem rather different. So plus a equals 3, plus a equals 3. This part here, this part here. You see how it is different here, and you see how it is different here. This would be the wrong version of it. This would be the correct version of it. But it says first.sh line 5, command not found. And then it echoes prints out the echo command and executes the echo command, meaning that it actually prints out the number 3. So these are the 3 options that you can use for debugging. You can either use them with set, as I've shown you with the -v, or you can use them with sh and dash straight from the terminal itself. Whichever way you prefer, whichever way suits the situation more. Anyway, I'm gonna go ahead and bid you farewell, and I'll see you in part 2.